Alright everyone, welcome to another session of our 60 plus days LeetCode solving challenge where we solve LeetCode questions from easy to difficult. So for the second time in a row, we are going to be solving an easy question, which is question 27, remove elements. And it states, given an integer array norms and an integer value, remove all occurrence of value in norms in place, right? The order of the element may be changed, then return the number of elements in norms, which are not equal to value. Now they say consider the number of elements in norms which are not equal to value k. To get accepted, you need to do the following things. Change the array norms such that the first k elements of norms contain the elements which are not equal to value. The remaining elements of norms are not important as well as the size of norms. Return k, right? And then we have examples. They say this is how you're going to be judged and evaluated. They're going to evaluate norms and they're going to evaluate value. K, sorry. So that's a set. So this is a test that's going to be run. And we have examples where you have norms, right? You're giving norms as that, and then you're giving the value of 3 to remove all incidents of 3 and make sure that the first k elements, so we have like, when we remove all 3, what you have 2 2s, right? So the first 2 elements will be only 2, will be anything other than 3. That's the idea, anything other than 3. And the rest of the values don't matter. They can be anything, but they'll only check the first k elements. And that's the example, and this is the explanation. Now, the last problem we saw was remove duplicates. So it's almost a similar thing, especially the evaluation metrics. Similar situation there, where we have to think of the solution in a particular sense. So here's what I suggest, that we are going to follow the system we started last time, where we write the algorithm without the code in terms of words, and then we try now to implement. It was easier and straightforward and made understanding very easy. This is the second easy problem in a row, so we're trying it again. Okay, so we are supposed to remove every integer, and also we have the constraints. Okay, now we have the length of these can be 0, which is interesting. So if the length of norms can be 0, then when we have 0, so we're just going to do like if norms dot length. So first of all, we're going to get the length. So let's do the algorithmic part. Get the length of the array, the input array, right? Check if, or let's say handle cases of empty array or of single element, or let me say cases of empty array. Let's just say cases of empty array. So sorry, handle cases of empty array, which basically we are just going to return. Then handle cases of length of array length greater than 1. There's multiple elements in an array, right? Of greater than or equals to 1. So whether a single element and multiple elements. And we are going to do this by iterating. So to handle this, we are going to iterate the array till the last, right? And each time we iterate the array to the last, we're going to each time we iterate the array to the last, what we want to do check if check if the number let me see. All right, the same thing. We are going to keep the index of the last non-val element, right? So the last element that is not equal to val, right? Val element, right? So we're going to keep the index of it, but it's going to so index starts at 0, okay, which we are going to initialize somewhere up here. All right. I think we are going to initialize index of last non-var element, right? And then we're going to iterate. So when we initialize it, we are going to keep, so we are already keeping it there. So why keeping, so when we initialize it, this means that we are keeping the index of that, okay. I'm going to just put something like that. Keep the index of the last known element in the graph. So we are always going to keep that index, which means that somewhere in this loop we are going to update that index. And what is going to happen is we are going to check if current element is not equal to val, right? And if this is true, okay, so we do if true, then add the current element to the last index, okay, and it's going to start at 0, and then we are going to increment the last index, okay. And so basically yeah, that will be it. And then we will so add the current element to the last index of the norms of the input. This is the last index, the last non-val element, the last non-val element index. Okay, let's put the last non-val elements index, right? So we are going to keep this one. We're going to start here and we'll keep it. So when we meet a new value, when we meet a value that's not equal to 2, we're going to add it there. Then we're going to increment this index to be the next one. And then we're still going to check across, or meet the next one, we'll add there. Only like that. When we come here and you see that it's still the same one, it's still the same, we just want to skip. And so basically, increment the last index, but we're not, so increment the last elements index. That's what we are incrementing. So it will be initialize index of the last non-value elements, yeah? And then, yeah, I think that's all. and then we simply just return. So if I extend it for it to be just good, return. Also, we need to have count. The good news is that we don't need count. We don't need count. We need count because we have the index here. The index is going to be the first one. If there is nothing there, then it's 0, right? Then the element 0, so it's 0. The index is 1, the element is 1, the index is 2, the element is 2, the index is 3, the element is 3. So if it comes here and initializes, it then pushes to the next index. It comes and pushes there, it becomes 1, okay? And pushes to the next index. Yeah, so that is correct. Because if it's just one element, it's just going to say, okay, 0 there, and then it's going to come and increment index to be 1. You understand? And then that's the last non-val index to be 1, and we're going to return, which coincidentally and actually accurately, it is the length of the array that we want to return. So we just want to return the last values index. Right? And that's the solution for this one. Let's go ahead and try to implement it. So get the length, which is int, then is equal to norms dot length, right? And then we are going to handle the case of empty array. So we're going to if length is equal to 0, we're just going to return 0. Okay, that's all for that. Then handle the case n less than 1. So we're going to do for int I initialize the value. So we need to get this just before, like, yeah, just before. So we want to do int last element index. Do we have to do index? I just put int index, right, equal to 0, right? And then we have for I equals to 0, right? I less than length. We have I plus plus. And we just have to return index here. And we have to iterate the array. So here we handle cases, which basically iterate the array. So we check for, let me kind of then back. We check if current, so if current, so norms I is not equal to val, then we want to handle this case, right? And that will be it. And then we have if true, then add the current element. So we want to do we want to do norms dot, so norms current equal to norms I. Then so it will be like increment. So then we now have to increment the last element index, which will be current plus plus, and we're going to do that. However, if it's not, it's just going to skip while I is going to iterate, and we're going to have that. So let's do a quick check. I think that's the solution. I mean, based on the fact that we saw the last one similarly, hopefully this was not supposed to be taking time, and it's not taking that much time. Let's run that and see. Okay, obviously definitely forgot some syntaxes. Here we go. Those are good reminders to check your syntax when coding. Okay. And what does it say is current, oh, index, sorry. So I am taking the solution from, so the solution from the last one we did, I'll use current. So yeah, there we go. That's, I think the case, this one is just simple, right? It's easy and straightforward. And yeah, there we go. That's easy, right? Easy peasy. This was good. This was really good, actually. Excellent. So we have our solution, and I think this is the most optimized solution out there, right? And it is well commented. There's nothing too much. If you watch the last video, then this should not be new. This should be easy. There's nothing too crazy about this. It's just logic, basic logic. This is all, and that was, well, it's easy. And we're going to be solving the next question, but not in this video. So the next video we're going to solve the next question. So solve each question per video. If you don't understand, so leave your worries below the comments. If you have some different approach which you solve and you use to solve this problem, please kindly leave it in the comments. If you have like a GitHub, I could check it out. I would love to see different approaches. I would love to see your time complexities and your own solutions to this. If you have some questions, please follow up in the comments below. Also, like, subscribe, and share. It helps me, and it also, encourages me to make more of these videos. You can connect with me on Instagram, Facebook, WhatsApp. Instagram, Facebook, LinkedIn, and they're all left in the description below of these videos. Of all my videos, actually, all of those contacts will be left below. Alright, so thank you very much for watching, and see you next video.